This video will discuss lesson 1.1. It is the discussion of the three main undefined terms in geometry. First, we'll get some definitions down here, and so you can pause the video and you can get these definitions down. I will continue on though, so please pause, get the definitions down, and we will continue. Alright, the first undefined term we will look at in geometry is what is a point. Now, a point is just a location in space represented by a dot. We remember graphing when we graphed in algebra that we would go over here and we'd go 2 over and we'd go 1 up and we could put a point right there. Well, all that point represents is that location. Okay, a point has zero dimensions. Because there's no length, there's no width there. It is infinitely small. It just represents that point. Okay, that spot in the plane. Now, to name a point, we didn't name them much in algebra. Geometry will name them a lot. To name this point, all we're going to do if we want to name it is put a capital letter by it. Okay, so if we wanted to draw an example, go over here. Here's a location right here. I could name this point B. All right. And we would just name that capital B. We wouldn't write out point, we would just put capital B. We could put another point, point C, D, and if we get another point over here, E, we could actually connect those points with segments and create a two-dimensional shape, alright? But we would just name that point B, point C, so on and so forth. The next one, again, you can pause this and get the definition down. A line is made up of points going in one direction forever and ever. Okay, you remember drawing lines last year in algebra? Well, you'd plot a few points, you would take your straight edge, you would draw the line through those points, and you would always finish with the arrowheads. Or my guess is last year your algebra teacher would take a point off if you didn't put those arrowheads on there. Now, a line has one dimension. Normally what I say is a line goes either left and right, or a line goes up and down. It sounds like two directions, but it's only one dimensional. And you got to remember that a line will go on in each direction, left and right here, forever and ever, amen. Now we have two ways that we will see this year how to name a line. The first one is what I'm going to do is a lowercase, and it's normally going to be cursive letter end of line. So what that means is if we look at this line, A is capital, B is capital, C is capital, D is capital. These name the points that are on that line, so does E down here. If we come outside to the end, and notice how we're going to write it towards the end of the line, this lowercase kind of cursive M or italicized M represents the name of that line. So down here where it says name the line three different ways, that's one way we can do it. We can just say M. Now notice lowercase kind of cursive M. We don't have to write line out there. Right? Here is the other way. We can name this line another way simply by naming 2 points on the line. Okay. Now, last year in algebra, you had to have 2 points. Now, normally your algebra teacher made you plot a few more than 2, but that's just for accuracy. If you plotted 2 points, you could draw that line through there. If I only have 1 point, I could draw as many lines through there as I want. But once I name or find another point, there is only one line I can draw through those 2 points. So we just have to pick 2 points on there. So like if I pick the points A and B, we just write AB, and then here's the symbol for line, because my guess is you don't want to write line out every time. You put the little arrowhead symbol. This is the line symbol, the line bar above it. This is literally read line AB. It's the line that goes through A and B. So if we look at this, we could come over here and name it another way. Let's pick 2 more points. Line BA would be the same thing, so let's go to line BC. We could also call that line CB. And we could keep going, go line CD. There you go. Those are the two different ways to name those. So we can actually have that little lowercase cursive letter on the outside, or just pick 2 points on there and name it. Now, you notice we have 4 points here on the same line. So what do we call points that lie on the same line? Those are called Good math word right here, good geometry word, collinear. And that's what collinear means. The definition for collinear is they're points that lie in the same line. When you hear the word linear, you need to start thinking line. Linear means line, line means linear. Okay, so you got to hear when you hear the word linear or you see a line, start thinking linear. All right, now, collinear points that lie in the same line. That would be A, B, C, and D in this. A, B, C, and D. All four of those points up here are collinear. Now, the one that's not collinear with those points would be E. So what we say that is that is non-collinear. Non-collinear. All right, so we have all these points up here. E would be non-collinear with A, B, C, and D. Now, I always like to ask this question: are B and E collinear? Well, right here, we don't have the line drawn, but could we draw a line that goes through B and E? Yeah. So those 2 points, any 2 points are collinear because I could draw a line through any 2 points. It doesn't really matter. Now, 3 points could possibly not be collinear. If we look at B, E, and C, B, E, and C are non-collinear there. All right, so those are 2 good definitions that we'll see again and again here. Collinear simply meaning that they're on the same line, and non-collinear means they're not. All right, so let's do some drawings. You will need your straight edge, and you're going to have to draw these. So this is literally read, draw line XY. So all you're going to do, take your straight edge down there. You're going to draw a line. Now remember, a line goes on forever and ever, amen. So you need to extend those out. You need to put your arrowheads on each one. All right, so now when you draw that, we have 2 points, X and Y, that are on that line. So we will put point X here, point Y here. Does it matter where they go? No. I just don't like when people put them way out here and put an X here because that's the arrowhead. Put it just inside that. All right, so that's the best way to do it. All right, that's it. Now, this is draw a line XY. So this right here, capital letter, this just says draw point C. That's how easy this is. We draw a point, we name it C. Done. That's all we had to do right there. Do not get this confused with down here. Well, though you'll get this confused with here in a little bit when we talk about planes. This is point C. If there's nothing written there and it's just capital, that's a point. Now, lowercase, this is a lowercase n, so that is not a point. That's a line. So we're going to draw a line in. So again, we're going to take our straight edge. Remember, if I grade it and you do not use a straight edge for your drawing, I do not grade it. So this is line, and then we just got to name it in. So I'm going to come out here and name it kind of a cursive lowercase n. So that's how we draw a line in. Now, number 4, we're going to draw a line AB. We need to make sure that we can read this properly, because if we can read it properly, we can write it properly. Draw a line AB that intersects line CD at E. So we're going to draw 2 lines, line AB, line CD, and they intersect at, remember that's point E, but we don't write it. All right, so we're going to call this A and this B. So there's line AB. We're going to call this C, this D, and then those 2 lines intersect at point E. Another little geometry thing, when you intersect 2 lines, they're going to intersect at a point. All right. Number 5, draw DEF that are collinear, meaning DEF are all on the same line. So we might as well draw a line and put DEF on there. So we're going to go D, E, F. Doesn't matter where or how far apart they are. Remember, the line goes on forever and ever, amen. And with a G that is non-collinear. So G is non-collinear, so we just have to go somewhere off that line, whether we're above it or below it. Make a mark and go point G. All right, so we will draw these, and you will be quizzed over those as well. All right, a plane. Again, you can pause the video right now. Get the definition down so you're ready to go. All right, so plane being a flat surface made of points that extends in 2 directions forever and ever. You guys dealt with planes a lot in algebra. Your coordinate plane. So it extends in 2 directions forever, meaning it goes left and right forever and ever, and then it goes up and down forever and ever. There's your 2 dimensions. Now, what we normally talk about here are 2 dimensions. For a line we would have considered our 1-dimension length. For a plane, we have two dimensions, and those dimensions are going to be what we'd say length and width. And if you think about, well, how do you find the area of a rectangle? Well, it's length times width. And those are the two dimensions we normally talk about when we're talking about planes and two-dimensional shapes. All right. Named by. Now, we can name a plane multiple ways here as well. There are two ways. Two ways to name it. So when we come down here and name the plane at the right three different ways, we'll do that, but there's two ways to name it. First off, you can look for a bold capital letter in the corner. Okay, that's the first way. So if you look at this drawing down here, this sketch here, the bold capital letter in the corner is this little K right here. Notice there's no point around it, like X has a point, Y has a point, W has a point, Z has a point. There's no point by that. So we could call this guy plane K. Now remember, I can't just write capital K because capital K would kind of say that, hey, what's point K? So we need to write plane out on that one. All right. The other way you can name this guy over here is by writing plane and then followed by three non-collinear points. So we want to look at this and we say, all right, what are 3 points that are non-collinear? So if we look at this graph, or this chart, I would not pick X, Y, and W because to me they look collinear. So what I would say is I'd take X, Y, and Z. Those are non-collinear. Kind of form a little triangle there. So what we would say that is we would say that would be plane. It's still plane K, but it's also plane X, Y, Z. Right, now another way we could do that is just pick three different non-collinear points like W, Y, and Z. So we could also call this plane W, Y, Z. Plane Z, Y, W, plane Y, Z, W. It doesn't matter order there. Now points in the same plane are called, so points in the same line were called collinear. Points in the same line were called collinear. So points in the same plane are called coplanar. And what you have to remember, guys, we can have infinitely many points in this plane. What we have drawn here is we only have 4 of them labeled, W, X, Y, and Z. All right, so at points that are not in the same plane, then this is called non-coplanar. So those would be points that are not in the same plane. Easy way to think of this is if you think of a classroom, you could draw infinitely many points on the front chalkboard, and then you go to the back chalkboard, and you draw infinitely many points of those. All those points on different chalkboards would be non-coplanar. They're not on the same plane. All the points on the front chalkboard would be coplanar. All right, so we're going to do some drawing right now. We're going to draw plane Q. Now, on your geometer, you have a handy-dandy little guy to draw planes. If you look on your geometer and find number 10, it's a little parallelogram. If you use that to draw your plane, it makes it nice and pretty. So that's what I would do. All right. So you lay your number 10 down. You sketch that bad boy. It's going to look something like this. And that's a nice, pretty plane right there. All right, so we have a nice, pretty plane, and we need to name it Q. So go ahead and name it Q. Remember to name it Q, we're going to put a nice, big, bold, beautiful letter right there in the corner. So here is plane Q. I'm going to make it nice and bold. Remember, we're not going to put a point around it because that's just naming the plane. And where A, B, C, and D, are coplanar. Okay, so A, B, C, and D are going to be on this plane. A, B, and C are collinear, so we need linear. So I'm going to go ahead and draw a line on there. Do you have to? No, but they're going to need to be on the same line anyway. So I'm going to go ahead and sketch it. And we'll put A, B, and C on there. So A, B, and C are collinear. And E is non-coplanar. So remember, we had A, B, and C are collinear. D is coplanar with this, so D is on this plane. And then E is non-coplanar. So E, like if you're writing this on a piece of paper, it would have to be like on a different sheet of paper or underneath on the desk. Okay, so it has to be non-coplanar. Now to show that in a drawing, here's how I'm going to show that in a drawing. I'm going to put E above it here. And then the way I'm going to show this, you got to remember that this plane extends this way infinitely. So some people might think, well, if you keep going this way, it's still going to be included in that plane. So what I'm going to do is I'm going to draw a line, a little dashed line down. Say, hey, this guy is above it. So now that kind of shows that, hey, I'm above it. Okay. So that covers everything in that drawing. A, B, C, D are on the plane. A, B, C are collinear. E is non-coplanar. All right. So let's go over here to number 7. It says draw plane X intersects plane Y. So we're going to have to sketch 2 planes. So we have 2 planes. And we're going to intersect them at line AB. So plane X intersect plane Y at line AB. So here's how we do that. And I'm going to show you how to do that with your geometer. So plop down that number 10 again. We sketch this. And then what you're going to do is you're going to take your 10. You're going to turn it. Okay, so now your geometer is more or less upright, and it looks like this. That would work, okay? And you'd have your intersection coming right through here, but these would kind of be slanted towards each other. I'm going to draw them like walls. So they're going to kind of intersect at a 90-degree angle. So what you want to do with that is take your geometer now and flip it. Okay, so flip your geometer over, and it's going to look kind of like this now. Alright. So to me that looks a little better. Again, yours would look better than mine just because of the way this program works. But then what we can do is there's plane X, nice big bold beautiful letter. Here's plane Y, and again it doesn't matter which one's which. Nice big bold beautiful letter. And then their intersection would be along here, so we can just go ahead and sketch that intersection all along there. And then now what we need to make sure that we have plane X, we have plane Y. We need to name this line AB. It's a line already with our arrowheads, but I need to put a couple points. So anywhere on this line, you can come out here, you can come in here. I already have these drawn where they intersected at, so I'm going to call that point A and that point B. Again, if you wanted to come in here, you could. Out here, you can. It doesn't matter where they're at. But we have line AB. So now these are just naming the geometrical term that best models each object. So if you think of a tip of a pen, like you push your pen down on your sheet of paper, you get a little dot right there. Well, what does that represent? That to me would be a point. All right. Now the ceiling, if you look up, the ceiling in this room is a nice flat surface. Again, if you could imagine it extending forever and ever in all directions or 2 directions, to me that would be a nice pretty plane. Okay. Now a tightrope pulled nice and tight is going to kind of represent a line, even though in all actuality it'd be more like a cylinder type thing. We'll get there when we get there. Number 11, a partially open folder. So if you think of a partially open folder, you have 2 sides to it. Well, those sides extended in all directions infinitely would be planes. And those 2 planes would intersect right there at that crease, and the crease would kind of be representing a line. So what I'm going to say, two planes intersecting in a line. Number 12, a pixel on your computer. Now you got to think really, really small here. A pixel on your computer is kind of like number 8 was. That would represent a point. Even though if you got infinitely small, it would be kind of like a little square probably. Let's look at this diagram right here. We're going to use this picture. We want to know how many planes. Now this little guy right here has 1, 2, 3, 4, 5 little edges around the bottom here. So that would be a pentagon, and then this is a pyramid because it comes to a vertex up here. So this would be a pentagonal pyramid. Now each of these triangular faces, if we extend in all directions forever and ever, that would be a plane. So those triangular faces there represent planes. What we want to know is how many planes are in this figure. So remember we said we had 5 around here, so we have 5 of these triangles. There's nothing up top, and then we have the bottom plane, which would be 6. So there are 6 planes there. We want to name 3 points that are collinear. So we got to remember the definition of collinear. Remember, linear means line. So we are on the same line. We need 3 points on the same line. So we have to look over here and find 3 points on the same line. Here, here, here. So we would say J, K, D. And I'm going to separate those with commas just to say that they're 3 separate points. Name the intersection of plane HDG, so plane HDG. So we named it with 3 points. So let's go over here and find plane HDG. Here's H, here's D, here's G. HDG. That would be this front plane right here, that triangular plane there. That I guess can't say that, but that triangle right there represents that plane. And then plane X is this bottom guy. Well, if you look at this plane right here, what points does it share in common with plane X? Well, that would be H and G. So the intersection would be all along that line HG. And we're going to write that. We're going to say the intersection of those two planes is line HG. Two planes, if you can imagine the wall and the ceiling as being planes, those planes intersect all along that corner. Not just at one point. They extend all along there, so two planes will always intersect at a line. Okay. Now we're looking at number 16. It says, at what point do line HD and line JK intersect? So now we're looking for the intersection of two lines, and to me, if you just kind of look at the intersection of two lines, they intersect at a single point. So we need to find the point at which they intersect. So let's trace. Line HD, that would be this guy. Remember, extends forever and ever, amen. And line JK would be this guy right up here, and it extends forever and ever in each direction. So they intersect right there, which is point D. Now remember, we don't have to write point D. We have to write plane out when we name it, but we don't have to write out point. So all we have to do is do capital D. Now, at what point do LM and EF intersect? Okay, so we're looking at LM. Now, if you look at LM here, LM does not lie on that plane. LM would be like if you jabbed your pencil through your piece of paper. If this is your piece of paper right here, plane X, your pencil would go through it at one point and then come out the underneath. That's why it's dashed, and then come out the bottom down here. So that does not lie on the plane. It just goes through it. The only point that that line is on the plane is right here at point L. So we want to find the intersection of LM, this line, and EF, this line. Now EF is on that plane. So right here, if you look, that's dashed because it's hidden. EF looks like it kind of intersects it, but it actually doesn't because LM only is on the plane right here. So what do we say here? No INT, no intersection. Now, some of you might have a good geometry word in your head right now called parallel. We'll explore that later on, but those lines are actually not what we would consider parallel in geometry. But again, we'll get those definitions later on. All right. The last definition here is space. Space is the boundless. It's a three-dimensional set of all points. And number of dimensions, it's three-dimensional. Now, what would represent this? This would be like your cereal box, where you have a three-dimensional prism. That's a nice rectangular prism. Well, we think of that as being three-dimensional. It has space. It has volume. Okay. So our dimensions here would be length, width, and then the third one we normally associate with that would be height. Okay. All right. So we have the three dimensions there. All right, so you can finish your worksheet now, worksheet 1.1. If you do have any questions or you would like to check, please come in and see me. And thank you.